Every day you type a web address and instantly reach your destination. It feels like magic. But behind this seamless experience is a complex global system. Rules, standards, hidden security risks. The journey from typing a domain to seeing a website is anything but simple. Today, we'll pull back the curtain on this process, focusing on internationalized domain names, or IDNs. IDNs let billions access the web in their native scripts, Cyrillic, Arabic, Chinese, and more. But this inclusivity brings technical and political challenges, as the internet's original design never anticipated such diversity. Let's dive into the surprising complexity behind every web address you use. Our mission is to reveal the hidden machinery behind domain names. We'll explore the layers of governance and technology that make web addresses work. This matters for accessibility security, the fight against online fraud. We'll also see how AI must understand these complexities to keep us safe online. At the heart of it all, the dual identity of every internationalized domain name, the U label for humans, the A label for machines. Understanding this duality is the foundation for everything that follows. Consider a domain like schlegel.com with an umlaut, human-friendly as a U label. But the DNS only understands ASCII, so it needs a translation, the A label, like xn-schlegel-z2a.com. Punycode is the system that makes this translation possible. The XN prefix signals a Punycode encoded string meant for machines, not humans. This dual identity is a compromise, letting a global internet run on an ASCII foundation. Sometimes the technical details leak through, reminding us of the system's complexity. For AI, understanding these leaks is essential to navigating the web safely. The U label and A label are just the start. Governing which characters are allowed in domain names is a complex, multi-layered process. The IETF sets the technical standards, Punycode IDNA 2008 defining which Unicode characters are valid. Detailed rules such as RFC 5892 specify which characters are permitted or restricted. Special rules handle right-to-left scripts, Arabic Hebrew, to prevent confusion and security risks. For example, mixing European numerals. Arabic Indic numerals in one label is strictly forbidden. These rules protect usability and security on a global scale. The U label and A label form the core of every internationalized domain name. U labels are for people readable and culturally relevant. A labels are for machines ASCII only, ensuring compatibility with the old internet infrastructure. Every non-English domain name is a two-faced entity, the name you see, and the code that makes it work. This dual system is a clever hack, allowing a multilingual web on an ASCII foundation. It's the first layer of complexity we must understand. Without it, the global internet as we know it wouldn't exist. The magic behind this duality is Punycode. For Strasse.com, the A label becomes xn-stray-ok.com, gibberish to humans but clear to machines. Punycode encodes non-ASCII characters into ASCII flagged by the XN prefix. This translation lets the global DNS handle requests without error. The system is a patch on the original ASCII-only design, enabling billions to use the web in their own languages. Your browser handles the translation automatically. The internet only sees the A label. It's an elegant solution, but as we'll see, even the best patches have their quirks. This entire phenomenon, hiding the complex A label behind the simple U label, is what computer scientists and engineers refer to as an abstraction. An abstraction is a way of hiding complexity to make something easier to use. The steering wheel in your car is an abstraction that hides the intricate mechanics of the steering rack, power steering pump. Similarly, your browser's address bar is an abstraction that is supposed to hide the messy technical details of DNS lookups, Punycode translations. It's designed to give you a clean, simple experience, letting you focus on where you want to go, not how the system gets you there. However, this particular abstraction is often described as being leaky. A leaky abstraction is one that fails to completely hide its underlying complexity. The technical plumbing, in this case that strange XN, Punycode translation, still leaks through into what is supposed to be a purely human-friendly experience. You have likely seen this leak without even realizing what it was. You might see the cryptic A label appear for a split second in your browser's address bar after a page loads, or see it displayed in the status bar at the bottom of your screen when you hover your mouse over an internationalized link. This leak is a constant, visible reminder of the internet's ASCII-first heritage. It's the system showing its seams, revealing the underlying patchwork that holds the multilingual web together. Every time an XN string appears where a familiar name should be, it's a sign that the abstraction isn't perfect. This isn't necessarily a bug, it's often a deliberate security feature by browsers to prevent certain types of attacks, but it shatters the illusion of simplicity. It reminds us that we are operating on a system that was fundamentally built for one language and has been painstakingly adapted to serve many. For the average user, this might just be a moment of visual clutter or minor confusion. But for a developer, a security professional, or an AI system trying to make sense of the web, this leakiness is a significant detail. It signifies that you cannot trust the surface-level appearance of a domain name alone. You must always be aware of the dual identity and the potential for the underlying technical reality to bubble up to the surface. It proves that to truly understand the system, you have to look past the abstraction and get familiar with the plumbing itself. This dual identity of U labels and A labels and the leaky abstraction that connects them is just our first stop. It serves as the foundational building block for everything else we are about to discuss, but it is merely the tip of a very large and treacherous iceberg. Understanding that Strasse.com becomes xn-stray-ok.com is step one. But the real complexity doesn't come from the translation itself. It comes from the sprawling, multi-layered and often political process of governing these names, deciding which characters are allowed in a U label, how they can be combined, and who gets to make the final call. The existence of punycode is just one small sign of the profound complexity an artificial intelligence must grasp. An AI can't just learn to convert between the two label types. It must understand why a certain U label might be valid for a German domain, like .d, but invalid for a global domain, like .com. It needs to comprehend the security implications of characters that look alike and grasp the subtle rules that govern the mixing of different language scripts within a single name. This is far beyond simple translation. It requires a deep contextual understanding of a global rulebook. So while we have established our fundamental concept, the visible versus the technical, this is only the entry point. The governance of these names is an astonishingly intricate system, a delicate dance between technical necessity, commercial interests, and cultural preservation. To truly unpack this complexity, we must move beyond the plumbing and look at what we are calling the tripartite foundation of domain name rules. This is a stack of three distinct and powerful layers of authority, each adding more nuance, more exceptions, and frankly more surprising facts to the system that determines a domain's identity. This journey will take us from the baseline technical standards set by engineers through the global governance policies enforced by a central coordinating body, and finally down to the specific, often stricter rules implemented by the individual registries that manage top-level domains like .com, .org, .d. Each layer has its own priorities and its own power to approve or deny a domain name. Getting a handle on these layers is the only way to appreciate why a seemingly simple web address can be the subject of so much debate, regulation, and risk. Okay, so we've established that every internationalized domain has a dual identity. U label for us, A label for the machines. But who decides what can even go into a U label in the first place? This brings us to the first of our three layers of rules, the technical baseline. This foundational layer is established by a group you may have heard of, the Internet Engineering Task Force, or IETF. These are the engineers, the architects of the Internet's core protocols. They create the blueprints that everything else is built upon, and their primary concern is making sure the system works reliably and predictably without breaking. Their master plan for making the multilingual web a reality is a framework known as IDNA 2008, which stands for Internationalized Domain Names in Applications, 2008 version. This isn't just one document, it's a collection of technical standards, requests for comments. Think of these RFCs as the Internet's bedrock engineering specifications. They are incredibly detailed, dictating precisely how software should handle these special domain names. This framework prevents chaos. A domain registered in Tokyo can be resolved correctly by a server in Toronto. Diving deeper reveals an almost obsessive level of detail. One critical document is RFC 5892, which assigns a specific property to every single Unicode character. It categorizes each one as p-valid, disallowed, or contextual. It's a massive table considering everything from accented letters to obscure symbols, ensuring only stable, unambiguous characters make it into the system. This technical layer also addresses specific linguistic challenges. For instance, the multi-part BD rule from RFC 5893 handles right-to-left languages like Arabic and Hebrew. It's not just about how the text looks on your screen, it dictates the required order of characters within the domain label itself. The rule is so strict it even prohibits mixing numbering systems, European numerals and Arabic Indic numerals, within a single label. It's a granular, procedural validation rule designed to prevent confusion and potential exploitation. So, the IETF engineers lay down the fundamental technical possibilities. They define what is theoretically possible within the system. But that's just the first layer. The second layer introduces the governance guardrails. This is where ICANN steps in, the Internet Corporation for Assigned Names and Numbers. ICANN's mission is to help ensure the stable and secure operation of the Internet's identifier systems. In the context of IDNs, their goal is to help unify the Internet and make it truly multilingual, but it must be safe and minimize harm for users worldwide. What's truly insightful isn't just the mission statement, it's how small, specific rules can have huge impact in preventing widespread problems. For example, ICANN develops and maintains the IDN implementation guidelines. These are policies that all generic top-level domain registries must follow. .com, .org, .shop. A new version, version 4.1, becomes fully effective by the end of April 2025. Its stated purpose: minimize the risk of cyber squatting and minimize consumer confusion. Here's a specific example from the guidelines. They explicitly forbid certain constructions, like putting hyphens in the third position or putting hyphens in the fourth position. So, a domain like a -b-example.com would be disallowed. It seems like a tiny, arbitrary detail. Who would even want to register a name like that? Why would ICANN bother banning it? It looks like a solution in search of a problem. But there's a good reason. The rule exists because of A labels. Remember the XN prefix that marks a Punycode string? The double hyphen in positions 3 and 4 is reserved for that. By prohibiting lookalike registrations, ICANN prevents a critical system conflict. It ensures software can always unambiguously identify a Punycode label. A tiny rule upholding the technical integrity of the whole domain name system. So, we have the IETF's technical foundation and ICANN's global governance policies. But this brings us to the third and final layer, and honestly, this is where things get truly nuanced. This is the layer where the rubber really meets the road because the rules are not monolithic across the Internet. The crucial question then becomes, after all these global standards and policies, who actually gets the final say on whether a specific domain name can be registered? The answer is the individual top-level domain or TLD registries. This is VeriSign for .com, DENIC for .d, and so on. These registries often implement rules that are even stricter than what the IETF or ICANN mandate, and critically, their rules take final precedence for their specific TLD. This means the definitive answer to the question, is this domain name valid, is almost never universal. It is always TLD dependent. What is perfectly acceptable for Germany's .de domain might be flatly rejected by the .com registry and vice versa. This creates a patchwork of different rule sets across the Internet, where each TLD operates like its own little digital country with its own unique laws. Let's take a concrete example. VeriSign, which manages the massive .com and .net TLDs, takes a very security-first, conservative approach. For instance, the Greek letter beta is technically p-valid under the IETF's IDNA 2008 standard. So, a domain like betatest.com should be technically possible. However, VeriSign would reject this registration. Their policy prohibits the mixing of different scripts, in this case Greek and Latin, within a single label. They enforce a rule of script purity within one part of the domain name to prevent user confusion and potential security risks. Similarly, VeriSign is very cautious about single-character domains. While you might want to register a short, snappy name like z.com, you'll find that it's not available to the public. VeriSign has generally reserved most single-character .com and .net domains for operational or other purposes, keeping them out of general circulation. This conservative stance prioritizes stability and security, sometimes at the expense of maximum linguistic flexibility. It shows that even if a name is technically possible and not banned by global policy, the final decision rests with the registry operator. While generic TLDs like .com have to follow ICANN's rules, the world of country code TLDs or CCTLDs can be even more diverse. Let's compare VeriSign's conservative approach with that of DENIC, Germany's .de registry. DENIC's philosophy is much more linguistically accommodating, specifically tailored to the needs of German speakers. Their rules permit 93 additional special characters beyond the basic set, including of course the German umlauts, AOU, but also, very notably, the EZ or sharp S character, that's SS. Now, this is where it gets interesting. Under the modern IDNA 2008 standard, the EZ is treated as a distinct character, not simply as an equivalent to SS. Because Dennis permits its registration, this means that Strasse.de using SS and Strasse.de using SS are two completely separate and distinct domain names. They can be owned by different people and can point to entirely different websites. If you're a German business owner, you might register one thinking you've secured your brand, while a competitor could snag the other, creating massive potential for confusion. Then you have the truly wild edge cases like emoji domains. Most emojis are explicitly disallowed by the IETF standards for use in generic TLDs like .com. They don't fit the traditional character sets, and there are concerns about stability and security. However, some CC-TLD operators have decided to go their own way. The registry for .ws, the country code for Samoa, explicitly supports and markets emoji domains. You can actually go out and register a domain like I love tacos.ws. This perfectly highlights the core principle. Local TLD rules can and sometimes do trump global standards. This creates fascinating pockets of the internet that operate under their own unique logic. What is technically non-compliant with the global engineering baseline can still be functionally valid and resolvable worldwide, all because a specific TLD operator decided to allow it. It's a bit like the Wild West in some corners of the domain world. This complex, multi-layered, and sometimes contradictory system of rules, IETF's technical foundation, ISAN's global policies, the final decisive power of individual TLD registries is the environment that any person or any AI must navigate to truly understand the Internet's naming system. This incredibly complex system, with its different layers of rules and policies, sounds like it's just begging for something to go wrong. And you know what? It did. This all sounds incredibly complicated, especially with all these different standards and policies floating around. I remember hearing about a time when different web browsers actually handled domain names differently, leading to massive confusion. This was a very real problem, and it was rooted in a historical schism between two different versions of the core technical standard, IDNA 2003, IDNA 2008. The transition between these two standards was anything but smooth. It wasn't just a simple update with a few new features. IDNA 2008 introduced critical incompatibilities with its predecessor. The way certain characters were handled, mapped, normalized before being put through the Punycode algorithm was fundamentally changed. This meant that for a small but significant number of domain names, the resulting A label, the machine-readable code, would be completely different depending on which standard your software was using. This created a deeply problematic and chaotic situation for the internet. Imagine the implications of this divergence. A single U label, the human-readable name U-type, could resolve to two entirely different Punycode A labels. This wasn't a theoretical problem. It meant that you could tell a friend to visit a specific website, but depending on the browser they were using, one that followed the old 2003 standard, one that had adopted the new 2008 standard, they could literally end up on two completely different websites, potentially owned by two different people. This was the kind of fundamental chaos the IDNA split caused. This schism was a nightmare scenario for anyone who cared about a stable, predictable internet. It violated the core promise of the domain name system, that a name should point to one and only one destination. To try and bridge this dangerous gap, a supplementary technical standard known as UTS number 46 was developed by the Unicode Consortium. It was designed to provide a transitional, compatibility-focused mapping to help applications handle both standards more gracefully. It was in essence a patch designed to stitch the two worlds back together and prevent the internet from fracturing. Despite the creation of this UTS number 46 patch, the damage was already being done. For quite a significant period, major web browsers just weren't on the same page. Different development teams made different choices about which standard to follow and how exactly to implement the compatibility layer. For a while, major browsers like Google Chrome, Mozilla Firefox adopted different compatibility modes and followed slightly different rules. This led directly to that nightmare scenario we just discussed. Typing the exact same internationalized domain name into two different browsers could lead you to two entirely different destinations online. This created a truly fragmented and unpredictable user experience. It was like speaking two distinct dialects of the same language where a single word could have two completely different meanings depending on who you were talking to. A user on Firefox might successfully reach a website, while their colleague using Chrome would see an error page or be directed to a malicious copycat site that had been registered using the alternate A label. This really undermined user trust and made navigating the multilingual web a confusing and potentially hazardous affair. This kind of deep-seated confusion isn't just an annoyance for the user, it's much more than that. It represents a fundamental breakdown in the reliability of critical internet infrastructure. But beyond mere confusion, this ambiguity opens the door to something far more insidious and dangerous. This leads us directly to what is arguably the single most significant security threat posed by the complexity of IDNs. This threat is known as the homograph attack, and trust me, this is where the story gets truly unsettling. A homograph attack is a sophisticated phishing technique that exploits the very nature of internationalized domain names. It leverages homoglyphs, characters from different scripts that look identical or nearly identical to the human eye, but are completely different characters to a computer. An attacker can use these look-alike characters to craft a fraudulent domain name that visually impersonates a legitimate, trusted website, tricking users into handing over their sensitive information. Let's break down exactly how a homograph attack works, because the deception is, honestly, chillingly effective. Imagine an attacker wants to steal credentials from Apple users. They can register a domain name that looks exactly like apple.com, but instead of using the standard Latin letter A, they substitute it with the Cyrillic letter A. To your eyes, as you glance at the link in an email or a social media post, the two look absolutely identical. You would have no reason to suspect that apple.com with a Cyrillic A is not the real apple.com with a Latin A. You literally cannot tell the difference just by looking at it. That is the power and the danger of this attack. This idea of something looking one way to you but being something completely different to the computer is profoundly unnerving. When you click on the fraudulent link, your browser, seeing the Cyrillic character, correctly resolves the Punycode A label for that specific domain and takes you to the attacker's server. There, you'll see a pixel-perfect copy of the real Apple login page, and you'll confidently enter your username and password, handing your credentials directly to the criminals. This is not a theoretical vulnerability. It's a classic and highly effective phishing technique that has been used in the wild for years. It preys on the limitations of human perception and our natural tendency to trust what we see. The entire security model of visually verifying a domain name in the address bar breaks down when you can no longer trust your own eyes. The very system designed to make the internet more inclusive, the use of multiple character sets, becomes a weapon that can be turned against the user. This is precisely why registries like VeriSign are so strict about their script mixing rules. Prohibiting a domain name that contains both Latin characters and Cyrillic characters within a single label is a direct preventative measure against this exact type of homograph attack. It's a blunt instrument, to be sure, and it limits some legitimate uses. But it's a trade-off made in the name of security, an attempt to close the door on one of the most deceptive threats that IDNs have introduced to the digital landscape. The rule exists as a direct response to this risk. These homograph attacks don't just come in one flavor, they manifest themselves in a few distinct categories, each with its own level of subtlety. The most obvious type is the cross-script homograph, like the Cyrillic A for Latin A example we just discussed. This is the classic attack using characters from scripts like Cyrillic Greek, Armenian. This provides a rich pool of lookalikes for attackers to choose from when crafting their deceptive domain names. But then the attacks can get even trickier. You have what are known as mixed script confusables. In this scenario, an attacker might register a name like scopetech.com, but they subtly sneak in a Greek tau, which looks very similar to a Latin T. It doesn't have to be a perfect, identical lookalike. It just needs to be close enough to be visually confusing at a quick glance, making the fraudulent domain appear legitimate. This might even be technically allowed by the rules of some less strict TLD registries, making it harder to block automatically. And of course, we still have the old-school ASCII-only confusables that have been around for much longer. G00gli.com using zeros instead of the letter O, or Microsoft.com using R and N to look like an M. While this is not technically an IDN issue, it operates on the exact same principle of visual deception. It really highlights that the core problem is about exploiting the gap between how humans see text and how computers process it, a problem that IDNs have magnified exponentially. Certain scenarios are definitely higher risk than others. Single-character domains, for example, are particularly problematic because they lack any surrounding linguistic context, making them easier to misinterpret or impersonate. And as we've seen, scripts like Cyrillic and Greek are frequently exploited due to their visual similarity to Latin. This is precisely why understanding the intent behind the rules, like Verissine's strict script mixing prohibitions, is so important. Those rules are not arbitrary. They are a direct and necessary response designed to protect users by preventing these high-risk homograph attacks at their source. Given this immense multi-layered complexity, the technical rules from the IETF, the governance from ICANN, the specific policies of hundreds of TLD registries, and the persistent security threats like homograph attacks, it makes perfect sense that artificial intelligence is starting to play a significant role in this space. Honestly, the sheer volume of rules, exceptions, and potential risks is just becoming too vast for any single human to manage effectively. This really feels like a whole new frontier for trustworthy AI, moving beyond creative tasks or data analysis into the realm of navigating critical, rule-based digital infrastructure where mistakes can have serious consequences for users and businesses alike. And it's not just a theoretical possibility. AI is actively being integrated into the commercial domain industry right now. Its most common application is in AI-powered domain generation tools, which help entrepreneurs and marketers brainstorm creative and available domain names for their new ventures. Basically, you can input a few keywords about your business, and the AI will suggest a list of potential names, checking for availability in real time. Major domain registrars and web hosting providers like Ionos and others already offer these kinds of AI-driven services as a value add for their customers, really streamlining the creative part of choosing a digital identity. This growing application of AI in the domain space has highlighted a critical need for rigorous evaluation. And, this has led directly to the development of novel testing frameworks, most notably the AI Domain Polyglot Benchmark, or AIDPB. This benchmark is not like a standard AI test that measures language fluency or image recognition. It's specifically and painstakingly designed to test an AI's ability to navigate this incredibly messy, constantly evolving, and often politically negotiated system of global domain name rules. It's a specialized exam for a very specialized, high-stakes skill set that is becoming increasingly important. The AIDPB's purpose is to push AI beyond simple tasks like brainstorming catchy names. It challenges an AI to act as a knowledgeable, trustworthy advisor. It must be able to understand the subtle interplay between the different layers of rules, recognize hidden security risks, and provide accurate, actionable guidance. The benchmark essentially asks, can an AI not only memorize the entire sprawling rulebook of the Internet's naming system, but also apply those rules with sound judgment in complex, real-world scenarios? This is a crucial question as we begin to entrust AI with more responsibility over our digital infrastructure. The AI Domain Polyglot Benchmark is not about rote memorization. That's the key difference that sets it apart. The true test is whether an AI can apply the vast and often conflicting set of rules with what the benchmark's creators have termed synthetic judgment. This is a fascinating concept. It suggests an AI must move beyond simple pattern matching or information retrieval and begin to exhibit a form of reasoning that mimics the nuanced decision-making of a human expert. It's about evaluating a situation based on multiple overlapping constraints and providing a contextually aware answer, not just a technically correct one from a single rulebook. The AIDPB is designed to evaluate an AI's capacity to perform a wide range of sophisticated tasks. For example, it must be able to accurately judge whether a specific domain name is actually registrable, considering not just the characters involved, but also the specific script mixing rules of different TLDs like .com.d. It must also be able to seamlessly convert between the human-readable U labels, the machine-readable A labels, understanding the Punycode translation process, forwards backwards. This is the foundational technical skill upon which all other judgments are built, ensuring the AI understands the dual identity nature of IDNs. One nuanced capability the benchmark tests is distinguishing official TLD registry policies versus the more restrictive limits in an individual registrar's user interface. A domain could be technically permitted by the main registry like Verissine, but the website where you go to buy it, like GoDaddy or Namecheap, might still block the registration. Their internal validation can be stricter or simply outdated for complex IDN cases. The AI needs to understand the distinction between what is possible and what is practically available. The ADPB includes trap scenarios to test deep understanding. Strasse.d probes IDNA 2008 and Dennis rules for the ESIT. btest.com tests VeriSign's script mixing prohibitions. Test.onihao.com tests interlabel script mixing where the dot changes the rule. The AI must recognize that the dot separating labels can completely change the applicable rule, a subtle but critical distinction. This entire benchmark effort clearly ties back to the broader, urgent imperative for developing trustworthy AI, especially in areas that touch upon critical global infrastructure. The domain name system is not just a commercial marketplace, it is a foundational piece of the internet. Global commerce, personal and corporate identity, national security flawed or incomplete. AI advice in this area is not a trivial matter. Significant financial losses, severe brand damage, critical security vulnerabilities. The ADPB, therefore, serves as a vital microcosm for testing AI reliability in these high-stakes, rule-based environments. It demands what proponents are calling a human-centric AI, or HCAI, approach. This means the AI shouldn't just provide a simplistic, binary yes or no answer when asked if a domain is valid. Instead, it should provide nuanced, multi-part responses that augment human decision-making and act as an expert co-pilot, not an infallible black box oracle. A truly safety-aware AI needs to understand the intent behind the rules, not just the letter of the law. For example, it's not enough to say the Cyrillic A is visually confusable with Latin A. A helpful AI should explain why PayPal.com using the Cyrillic A is a high-risk homograph and likely rejected by the .com registry due to script mixing rules. Then connect that rule to its purpose, minimize consumer confusion, prevent cyber-squatting, thwart phishing attacks. This ability to connect rule to reason is crucial. It shows understanding of the spirit of the law, not just its literal text. The ultimate goal here is to avoid a phenomenon that some researchers call safety washing. An AI that seems safer because of raw capability may get answers right via brute force pattern matching without true alignment to safety principles or human values. It might output the right answer but without proper context, leaving a fragile, untrustworthy state. So, what does all of this mean for us and our digital world? What are the practical, real-world applications of this kind of sophisticated polyglot AI capability beyond just theory and benchmark scores? The potential impacts are significant and could genuinely reshape how we manage the internet's core naming system. For instance, consider the domain of policy simulation. AI could provide immense value to governing bodies like ICANN AI, could provide immense value to individual TLD registries, before a new policy, like a new set of character allowances, is even ratified, before a new policy, like mixing rules, is even ratified. A highly capable AI could be tasked with processing millions of hypothetical registrations or even billions of hypothetical registrations. It could systematically probe the new rule set for unintended consequences. It could discover potential loopholes that could be exploited by malicious actors. It could predict conflicts with existing rules at a scale and speed humans can't match. Think of it as stress testing new laws in a virtual environment before they go live. Another area with massive potential impact is enhanced DNS abuse mitigation. Today, mitigation can take as long as 8 days to remove a phishing site. That delay creates an enormous window for criminals to defraud users. A safety-aligned AI trained on ADPB could change this dynamic completely. Deployed to flag suspicious registrations at the moment of creation, the system could generate an immediate policy-backed alert. Warning, this registration for PayPal.com appears to be a high-risk homograph. That shift could cut response times from days to minutes and protect consumers. Okay, so after that whirlwind tour of technical standards, global governance, and terrifying security threats, let's bring this all down to earth. For anyone listening who might now be thinking of venturing into the world of international domain names for their business, their project, or just for fun, there is a hugely important practical distinction you need to understand. It seems like a subtle point of jargon, but getting it wrong can lead to a lot of frustration. I'm talking about the crucial difference between a domain registry and a domain registrar. They are not the same thing, not by a long shot. The registry is the wholesaler, the big boss for a specific top-level domain. Think of VeriSign for .com or Dennis for .d. These organizations manage the entire TLD. They maintain the authoritative database of all the names registered under it. And most importantly, they set the overarching policies, the main rulebook for that domain extension. They operate at the highest level, managing infrastructure and defining the laws of their digital territory. You, as a consumer, almost never interact directly with the registry. They are the behind-the-scenes powerhouse. The registrar, on the other hand, is the retail company you actually deal with. They are the storefronts that sell domain names directly to you. GoDaddy, Namecheap, Google Domains, Dynadot, and hundreds of others. They are authorized resellers who connect to the registry system on your behalf to secure a domain name. And here's the critical point. A registrar's own website, their user interface where you try to register the name, might prevent you from registering a domain that the main registry technically permits. Why on earth would they do that? Well, there are a few reasons. The registrar might have its own, stricter internal business rules, perhaps to avoid customer support headaches with complex domains. Their system's front-end or back-end might simply not be updated to properly handle certain complex IDNs or newer character sets. Sometimes it's a deliberate business decision to block things they find potentially confusing or risky. The key takeaway is this. What the registrar lets you do is not always the same as what the main registry allows. The retailer can have stricter rules than the wholesaler. This distinction naturally leads to a very practical question. If you are specifically looking to register internationalized domain names, especially complex ones, what should you look for in a registrar? Are some better equipped for the job than others? The answer is an emphatic yes. Not all registrars are created equal when it comes to navigating the tricky waters of IDNs. If your chosen name involves non-Latin characters, mixed scripts, or anything beyond the basics, you need to choose your provider carefully to avoid hitting a wall of computer says no, for no good reason. First and foremost, you should look for registrars that demonstrate robust and explicit Unicode support across their entire platform. This isn't just about their search box, it's about their management panels, their renewal systems, and their customer support. Look for clear published IDN policies on their website. Do they provide documentation on which languages and scripts they support? Do they have tools to show you the U label? Do they have tools to show you the A label versions of your domain? A registrar that is transparent about its IDN capabilities is far more likely to handle your registration smoothly than one that treats it as an afterthought. While many of the largest, most general-purpose registrars have improved their IDN support over the years, certain specialist companies are often recommended within the industry for their expertise in handling these complex cases. Dynadot 101 Domain. They often provide more knowledgeable, targeted customer support for these specific issues, which can be invaluable when you're trying to figure out why a technically valid domain is being rejected by another provider's system. Ultimately, whether you decide to track your growing domain portfolio in a simple spreadsheet, or eventually use some of the advanced AI-enhanced tools that are now starting to emerge, this foundational knowledge is vital. Understanding the nuances of registry rules versus registrar rules, being aware of potential pitfalls like homograph attacks, and choosing the right tools for the job helps you navigate the complexities of the system effectively. It empowers you to protect your online identity and manage your digital assets in our increasingly globalized and multilingual digital world, ensuring you get the name you want without unnecessary roadblocks. This has been an absolutely incredible deep dive, hasn't it? We've journeyed from the seemingly simple act of typing a web address to uncovering a whole hidden world beneath the surface. We've seen how IDNs are both an amazing bridge to a truly multilingual web and a battleground for digital security. We've explored the complex interplay of technical standards, global governance, and the critical cybersecurity threats that define the Internet's naming system. It's easy to get lost in the technical weeds and wonder why this all has to be so complicated. But this deep dive into the messy reality of IDNs reveals something pretty profound, I think. It shows that the digital infrastructure we rely on every single day is far more intricate and actually far more human-centric than most of us ever realize. All of these rules, all of these layers of governance, and all of these technical complexities, they don't exist for their own sake. They ultimately arise from a constant, difficult, and ongoing effort to balance cold, hard technical constraints with messy, real-world human needs. It's a system built by people, for people. Think about it. The need for different languages to be represented online, the need for security to protect us from fraud, the need to prevent confusion between businesses, the need to respect cultural norms, these are all fundamentally human concerns. The entire complex structure, from the IETF's BD rules for Arabic script to Verisig's script mixing policies, is a testament to the effort required to make a single, unified technology serve the diverse needs of all of humanity. It's a negotiation, a compromise between what is technically possible and what is humanly necessary for a fair and safe digital society. And this brings us full circle. The challenge of building an AI that can reliably navigate what the AIDPB creators call this polyglot gauntlet is really a microcosm for the broader challenge we face everywhere. That is, the challenge of developing trustworthy, responsible, and genuinely human-aligned AI in any complex regulated field, whether it's finance, law, medicine, or other critical infrastructure. It's a powerful and humbling reminder, I think, that even the most technical problems we face online are, at their core, about understanding, serving, and protecting human needs and human values. So here we are at the end of our journey. We started with the simple, almost magical act of typing a web address and hitting enter. We've since traveled deep into the hidden machinery of the internet, peeling back layer after layer of abstraction to reveal a world of staggering complexity. We've journeyed from the dual identity of U-labels and A-labels. We've traversed the tripartite foundation of rules set by engineers, governors, registries, and faced the sobering reality of security threats like the homograph attack. What began as a simple click has revealed itself to be a delicate, high-stakes dance of global cooperation and compromise. The domain name system is so much more than just a technical directory. It is a living, breathing ecosystem that constantly evolves to meet new challenges. Linguistic diversity pushes up against the rigid foundations of legacy technology. The desire for an open global internet must be balanced with the absolute necessity of security and trust. The creation of frameworks like the AI domain polyglot benchmark underscores this new reality. Navigating this space now requires a new level of intelligence, one that can appreciate not just the rules, but the reasons behind them. What I hope you take away is a newfound appreciation for the immense human effort behind the digital world. Every rule we discussed, from the prohibition on mixing numeral systems in Arabic to the strict script mixing policies for .com, exists for a reason. These are not arbitrary technical constraints. They are thoughtful, sometimes imperfect, attempts to solve human problems. They are designed to prevent fraud, to ensure clarity, to enable communication, and to build a more inclusive digital space for billions of people, all while working within the confines of a system built decades ago. Ultimately, this deep dive into the arcane world of IDNs reveals a profound truth about everyday technology. Digital infrastructure is far more intricate and far more fundamentally human than most realize. Endless debates, dense policy documents, and complex technical standards reflect our collective struggle to make a single global network serve diverse human needs. Behind every protocol and every line of code, there is a choice being made about how to best serve people. As we conclude, it is fascinating to reflect on how this entire sprawling system is built upon a single foundational compromise. Punycode the XN, prefix the entire concept of A-labels. It is a constant, lingering ghost of the internet's origins. It is the ghost of an ASCII first world, a reminder that the initial architecture was never designed with global multilingualism in mind. We have spent the last 2 decades building an incredible, complex, and clever superstructure on top of that original foundation to make it work for everyone. This constant negotiation with the past is what makes the domain name system so compelling and so challenging. It means that true mastery of this space, for a person or an AI, is not just about knowing the current rules. It requires an understanding of the history. IDNA 2003, IDNA 2008 Security Vulnerabilities Policy Decisions. This historical context gives meaning to the rules and allows for the kind of synthetic judgment needed to navigate the system safely and effectively. And so, the next time you type a web address into your browser, perhaps you will see it a little differently. Maybe you'll see beyond the simple string of characters to the intricate web of rules and compromises that it represents. The engineers at the IETF defining character properties, the policymakers at ICANN debating hyphen placement, the registry operators in Germany, the registry operators in Samoa. You'll know that what you are doing is not magic. It's the result of decades of human ingenuity. This hidden world is a testament to our ability to adapt, to innovate, and to retrofit our creations to be more inclusive than their original designs. The journey to a truly multilingual and secure internet is far from over, and the rise of AI adds a powerful new dimension to that ongoing story. But by understanding the complexity that exists just beneath the surface, we are all better equipped to appreciate the delicate miracle of the global network we share, and to be more mindful citizens of the digital world we all inhabit.